messages are sent, and therefore an attacker is not able to pull the web key out of the packet until they have fully associated with the access point and they have entered the web key on their own. Shared key authentication is a method of authenticating that requires the use of web, and that's one of the main reasons why it's less secure, although it doesn't sound like it at first. Web encryption uses keys that are entered on both sides, the client and on the access point. The keys have to match on both ends for web to work properly. Shared key authentication uses web keys in two different fashions, and the process actually will describe both of those. The process for shared key authentication is actually quite simple, but it is also less secure, because first, a client will request association to an access point, very much the same as that of open system. However, the access point will then issue a challenge to the client. The challenge is randomly generated plain text, which is sent in the clear back to the client. The client is supposed to respond to the challenge by encrypting that challenge text using the client's web key and sending it back to the access point. Now here's where it gets kind of fun. If the web key encryption mechanism has worked properly, because the client does have the same web key, then that challenge is properly sent back to the access point and the client would be granted access. However, if it does not match, meaning that you've entered a random web key because you're trying to hack into the system, what will happen is the access point will send a second challenge using their web key. Now that I've got the second challenge, knowing that the messages are exactly the same, it makes it very easy for a hacker to derive what the web key is by using a password cracking program, because I've got the original message in plain text, and then I've also got the message encrypted with the web key that are exactly the same. So that's the reason why the shared key authentication process is considered less secure. But let's pretend that the access point did like what the client returned. The client did have the web key entered locally, and thus the access point was able to properly decrypt the client's encrypted message to verify that the challenge text was encrypted using the same web key. Through this process, the access point determines whether or not the client is real. If the client's key is correct, the access point responds positively and authenticates the client. If it's not correct, of course, it will send a second challenge. And that challenge is where we see the caveat of the shared key authentication. Now, you would think that shared key authentication would be more secure just because of its use of web. But rather, shared key does open the door for would-be hackers. And that's one thing to keep in mind. A lot of access points that you might buy out of the box will allow either open system or shared key. And what you've got to decide is if you're going to use wired equivalent privacy or WEP, you need to make sure that you choose to use it with an open system, as that will make your environment much more secure. So the rule of thumb for authentication security is that open system is more secure than shared key. That we've established. But what about other types of authentication security that we can use? One of the options is using shared secrets and certificates. Shared secrets are more or less just the web keys. However, certificates are another method of user identification that can be used with wireless networks. Certificates are placed on the client machine ahead of time. The placement is done so that when a user wishes to authenticate to the wireless network, the authentication mechanism is already in place on the client station. Both of these methods have historically been implemented in a manual fashion, but there are applications available today that would allow the automation of this process. You just need to decide exactly how you want to carry this out in your own network. In addition, there are quite a few emerging wireless security solutions that we can choose to use, including virtual private networks and 802.1x using extensible authentication protocol are probably some of the more popular. Many of these security solutions involve passing authentication through to a downstream or back-end authentication server from the access point, while keeping the client in a wait state while the authentication phase completes. Windows XP, for instance, has native support for 802.11, 802.1x, and Extensible Authentication Protocol, or EAP. Cisco and other wireless LAN manufacturers also support these standards, and Cisco even has a specific one which is known as LEAP, which utilizes the Extensible Authentication Protocol as well. We're going to see a lot of these become very common to the wireless LAN security market. And in this area, there's also very fierce competition between competitors that want to make sure that their version of EAP becomes the standard. Because as it stands right now, it hasn't really been standardized by any of our major governing bodies. The 802.1x and EAP, though, are probably some of the best new security solutions that we see in wireless areas. The protocol does work well for access points that need the ability to keep users disconnected if they're not supposed to be on the network, And also, because all of this works at layer 2, it's a very flexible replacement for things like challenge handshake authentication protocol using PPP for anything that works over local area networks. EAP actually allows plugins at either end of a link and has many different methods of authentication that can be used that are well beyond the old PPP challenge handshake authentication protocol. Really, this has been prompted by a need for stronger and more flexible alternatives for wireless network security and is becoming more and more secure as our technology continues to emerge. We do see a lot of extensibility into the back-end servers with Radius and TACX and utilizing Active Directory and lightweight directory access protocol and quite a few different mechanisms that can be used for back-end authentication with 802.1x and extensible authentication protocol. With EAP, we are going to have several different types that you'll want to be aware of. We do have the standard EAP MD5 challenge, and this is actually one of the earliest deployments of the extensible authentication protocol. It essentially duplicates the same CHAP-based password protection for a wireless LAN. Well, then we get into some of the more advanced. We have the Cisco EAP, which is known as LEAP, Lightweight Extensible Authentication Protocol. This is used primarily in Cisco wireless LAN deployments. It provides security during a few phases, during credential exchange, for encryption purposes, and also uses dynamically generated web keys that can be broadcast rotated, which means they can automatically change at certain time intervals. It also supports mutual authentication between systems. We have an additional component which is called EAP TLS for transport layer security, which is designed for certificate-based mutual authentication of the client and of the network. EAP TLS relies on client-side extensions and server-side certificates to perform authentication using dynamically generated user and session-based web keys that are distributed to the connection itself. Windows XP does include an EAP TLS client, and an EAP TLS is also supported by Windows 2000 and Windows 2003. EAP TTLS, which is designed for Funk Software and Certicom that have kind of come together to create this standard, is an extension of EAP TLS. It does provide for certificate-based mutual authentication of the client and network, but unlike EAP TLS, it requires only a server-side certificate, which is designed to run on Funk Software's steel-belted Radius component, which is one of those back-end authentication services which is used for centralizing authentication in wireless networks. The biggest difference here is that it does support not only just server-side certificates, eliminating the need to configure certificates for each wireless LAN, but it also supports legacy password protocols, so you're able to deploy it against your existing authentication system, such as Active Directory or Novell's NDS. It also will securely tunnel client authentication within a TLS record, ensuring that the user remains completely anonymous to eavesdroppers that are on the wireless link. Dynamically generating user and session-based web keys are also distributed back and forth between the client and the access point to further secure the connection. But there is another one which has been set up to really compete with EAP TTLS, and that's known as Protected EAP. This has been designed as a collaborative effort between Cisco and Microsoft. It is a direct competitor with the EAP TTLS, which is designed by Funk Software. It uses a tunneled server-side certificate and a username password credential for client authentication to the server. PEEP is supported in Windows XP and higher, and also supported by Cisco's ACS component, and also their wireless LAN client software for Cisco Aeronet. PEAP supports mutual authentication, which also adds increased security. Another element that you have is what's called the EAP SRP for Secure Remote Password. And this is very much like using a smart card. It's a secure password-based authentication and a key exchange protocol. And what it does is it solves the problem of having to authenticate users that only need to remember a very small bit of information as a secret, like a very small password or PIN number. The server will carry a single verifier for every user, which allows the server to authenticate the client. The biggest benefit with SRP is that if the verifier was compromised, attackers cannot impersonate the client. And this does solve some of the problems that we have with secure exchange at this level. It also exchanges a cryptographically strong secret as a byproduct of successful authentication with the small secret, which then enables the two parties to communicate securely, much more like IPsec VPNs would work. We also have one last one, which is known as the EAP SIM. SIM stands for Subscriber Identity Module. This is a mechanism which is